Okay, welcome to my talk here. My name is Dag Brattli. Work as an engineer for a company called Cognite in Oslo, Norway. And I'm so lucky that I actually get to write F# code 100% of my time in that job. But unfortunately, it's not Fable, but so it's mostly services, backend services, but still it's a good place to work. And if you are looking for opportunities, you can go to that webpage and see what job openings we have. And we have a lot of them. So this talk is about, call it Reactive MVU. So I hope you all know a little bit about Elmish. If not, this will be sort of inspiring on what you can do with Elmish, or Elmish-ish like experiences. So I had a talk or a workshop last year that was about Fable reaction, and I am calling it Fable reaction again. On the web page it will say Elmish streams, but now I'm taking back the old name because I don't need the dependency on Elmish anymore. You will learn a lot more about that during the talk. So I got some really great feedback after FableConf last year. And people said, this is awesome, but you need to make it even more awesome. So I've been working with the community for quite a long time, and we came up with some new ideas on how it should be done. So this is what I'm going to present today. And even some more changes that I recently did to the project. So Reactive is about streams and processing of streams. So what is a stream? You have event streams. Something happens, someone clicks a button, someone moves a mouse, that produces events. We can transform those events into messages that we can send. So if you're used to Elmish, you know that we have a lot of messages going. Those messages can be transformed into a model. The model can be transformed into a view. And the view can produce events. So there's streams sort of everywhere. At least that's what I saw when I first started working with Elmish. Oh my God, there's streams everywhere. So this is sort of what you can do with it. So to take it, tell a little bit of the story of stream processing, you have this project called Reactive Extensions, which is a library to compose streams using observable collections. And so this is basically an implementation of iObservable. And iObservable is quite simple. You have an observable, and you subscribe using an observer, and that gives you a disposable. So you have a stream, you can observe the stream using an observer, and when you do that, you get a disposable that you can dispose to stop subscribing. That's basically it. You can look more into it on the net. So with the reactive worlds, we basically start with a simple thing that you also see a lot in Elmish, that you have this dispatch function that is basically just a setter function. It's a function that takes a value and returns nothing. So you throw a value out there and hope that someone takes care of it. With iObservable, you have a setter of a setter function. So you have a setter where you can set this setter function, and we call that subscribe. What we will talk about today is a creation called Async Observer, which is basically an async setter function of an async setter function. So everything is async. And it doesn't stop there. You can go into many of these kinds of worlds with iCubeServable and iAsync CubeServable, and you can create whatever worlds you like. Today we are going to talk about async observers. So you could have used iObservable, so that would be something we could do on the workshop tomorrow, to use RxJS and write a mapping for that to Fable. Don't know if it already exists. But async Rx implementation of async observers. So it's basically the same thing as an iObserver, but just that every method is async. So that is because the observer wants to do side effects. And it's much easier to do a side effect if you return something async. The same thing with subscribe. You set up a subscription. That subscription might need to contact a service like Twitter or Facebook or something. So it's good that it's async. Makes everything easier. So it's basically the dual of what you find in F# called async sec, asynchronous sequences, or async enumerable, as it's called in C#. So it's a push-based collection. So we'll see how we can use this in Elvish type applications. So with Async Rx, we can transform streams, which means that we can create them, and we can create them out of thin air. You can sort of create events that are not there to begin with, like a timer. We set up a timer and then start producing events. We can filter streams, aggregate streams, split and merge streams, and we can time shift streams, which is really a fun thing to do. And we will look more at that. Then we have Elmish. So this is quite early talk, and you might not know what Elmish is, but you will learn more about it during these days, if you have not heard about it before. And Elmish is about this MVU, model view update, which is a quite simple abstraction, where you only have to deal with these two functions called update and view. But behind the scenes, there will be events. The events will become messages. Messages goes to update. The update produces a new model.
Your microphone.
Oh, sorry. The model gets fed to the view, and the view will provide, construct a new view, and the view will again produce events. There are some, at least for me, there are some problems with using Elmish, and that is the extensibility story is really non-existent. In Elmish, the abstractions are very fixed, and that is to make it easy for people like you to get started with it. So it's not that easy for me to stitch in this reactive work. And the coupling between the state update and deciding what kind of side effects you want to perform are, in my opinion, a bit complicated. You can use Elmish without commands, but when you start using commands, it takes some time to get used to. And I think that especially things like time handling, throttling, debouncing is not trivial to do using commands. So we can actually recode all of Elmish with Async Rx. And this is the implementation. That's it, except for we don't have commands here. But you start with some kind of stream. You produce, you send it into an accumulator, and you get new models. You take the models and map them to the view, and then produces a stream of views. And you can subscribe to that and render it with React. And this code actually works. So that tells me that we should be able to do more stuff by combining Rx and... We can take it afterwards, so I know how much time I have. And you also have the scaling story of Elmish, where every part is a part of the main part. So you have the application model, which consists of all the models of the subparts and the subcomponents. And you have the same thing for messages and views. And this gets really complicated when you need to have a mainstream with substreams and perhaps component streams within the substreams. And when you then have some part of the application needing to be on the server side, then things get complicated quickly. So I've been working for the last months to see how can I make this simpler, at least for me. So I think it's simpler. And I hope it will be something you also can use. So Alfonso sent me a message on Twitter telling that you might want to look into React hooks. So I started reading about them, and you have all these hooks that you have a state hook, reducer hook, event, memo, ref, and I had no idea what this was all about. So I started reading about them, and I actually didn't understand much. So I started doing what I always do when I don't understand things, and that is to start coding. So you can create a simple MVU using React hooks. And React hooks has, when you talk about that in a Fable setting, people often say that this is good if you want to make something small. This has not the power of Elmish and commands. So this is also an implementation of MVU that do not have commands. But we see it's really, really simple. You just use a simple reducer, give the update function. It will produce a model that you can give to the view function. So this works. Really simple MVU. But how should we take all of this and produce something that can handle streams? For streams, we have some problems, and that is when do we start streaming, or when do we restart streaming? And something other that is really important is when should we dispose or unsubscribe? You have a single page application and you switch between pages. The first page might have started a web request. Then you suddenly switch. What happens if you switch back? Will the old request suddenly reappear again? And also, something that we have tried for a long time is how can we change the stream while the program is running, so it's not something static. And in Elmish setting, we actually want to change the stream when the model changes. So this is where we try to take the electric eel of Rx and combine it with the elf, no, the dragon, the Fable dragon, yes, that's correct. So this is a bit small, but here is an implementation of a custom hook using streams. And the main idea is that we create a stream. I use a state hook to cache it so it doesn't get a new stream every time it runs. And then we call a stream function that is our transformation on the messages. And we say that this returns new messages, transform messages, and a tag. So we tag the stream and say that it can have a name. And then we use the effect disposable hook and give it the tag, because then React will know if the stream have changed or not. Which means that if the stream returns something new, then this effect will run. And the effect basically just subscribes the stream and feeds it to the original dispatch function. So it looks a bit complicated, but it's quite simple. It's just that the async Rx is a bit edgy when it comes to all the async handling, which doesn't fit well with inside React. but it's basically running okay. So we can show a demo of that. Let me see. And we have the, yeah, that was counter. We run the counter example, which is a default safe. Let us switch here, see that if it compiles. We can show the code. So this is basically the code here, that we create this stream component, have an initial model, view update functions, and we also add this stream function. And this stream function takes the model and just say that if it's loading, then we load the initial count. If not, we just pass through the messages that are produced. So this is the application that looks like this. So we can click here and everything works. We can also try this time flies example. Do I have time flies? So a little bit more advanced. Oh, let's go back. So this is same two lines to get this running. And then we have the stream, which takes the mouse moves and transforms them. It delays. It replaces every mouse move with this sequence and delays every character based on its position in that list. So then we get something like this. Which is quite fun to play with. But what we really want is to have stateful streams. And stateful streams is streams that can change based on the state of the model. And to make a stateful stream, we basically just have to take the stream we created and compose the state on the stream just curry it as a first parameter, or partially apply it. Then we use a reducer to create our model from this update function. We give the model to the stateful stream. We get back a dispatch function that we give to the view. And that gives us something that looks like this. Looks a bit complicated, but really it is that we have messages that go to update. Update produces a new model. We give the model to the view, and it produces React elements. But we know that the view can also dispatch messages, and those goes into the stream. The stream will most likely just give it back to the update, but the stream can also transform it using some filter or some you can do web request. You can take a message and transform it into a web request, and that response will then go back into the update function. So when it goes to the update gives a new model. The model goes to the stream, and we know if the model changes, then it might produce a new stream. So, another demo. Let me see. And this is sort of a silly demo that I created together with Roman Sakse, who I don't think is here this year. Let's see if, yeah. So this is a small playground project. It has two components, a magic component and an info component. And we see that nothing happens here. We can show the client. It has some initial loading of state, And if we look at the magic example, it has this component that basically the same. It's just a stream component that composes in this stream. And the stream will do basically different kind of stuff based on the model. So it's a bit complex. You can look at it on the internet afterwards. But it means that depending on the model, we can return different kind of streams. And we see that we tag the streams with a name. So the function we created earlier knows if it should dispose and resubscribe or not. So this means that we can click here and we suddenly get a stream because we have changed the model. The model will resubscribe a different stream. And this stream, so this means that we can say like FableConf. And then we have a new stream. So this model on this component down here is not doing anything. But what it is doing is that we can activate it, and it will create a WebSocket subscription to the server and start listening. But it's not happening anything yet. But we can say that we, instead of streaming the messages, just take the mouse moves and feeding them to React, we can send them to the server first. So we click here, and suddenly we have the messages going to the server, and this component down here now see what's happening. It still has this old message, so we can. It's probably just listening for the new events. Yeah. But the interesting part is to inspect here and see what is happening. So we can look here. If we clear this one, we can actually see what is happening. That when we click on this, then we see that Reaction is disposing the remote subscription and then suddenly subscribing the local subscription. So every time we change the model, we get a new stream. Yeah. A little bit slow when we have the debugger or this panel. So I need to go to the React workshop tomorrow to learn how to speed this up. And like this. So this means that if you have a single page application and you're doing different kind of stuff, you can let those pages start whatever you want of subscriptions, talk to some remote service. Whenever you click on a different tab, you can switch the model and subscribe something totally different. A different demo. Let me see. This is autocomplete. And the autocomplete I've been struggling with for quite some time to make the autocomplete component separate from the rest of the application. Let me see if we have the magic applies. Yeah, this is autocomplete. So here we have the component that we mount, and here we just add the autocomplete component. So this component is now set into the HTML we are producing, And we don't have to deal with this component. We don't need to know what kind of messages it produces. We don't need to know the model it has. We don't need to know anything about the view. We just say that now you can render yourself here. And we say when you want to search something, search Wikipedia for us. And when you have a result, call this dispatch function. And we can set some properties on how it should behave. So the autocomplete, sorry for the, it's a stream component that has this transformation where it says that when there's a keyboard event, take the full input of the input field. Filter, we're only interested in things that are more than 2 characters. Debounce it so that don't search Wikipedia whenever you touch. We want to only search Wikipedia if you wait for like 750 milliseconds. And we only need distinct results. So if you have already searched for this, we don't want to search once more. And we have some logic to know if the component is loading or not. And when we have that, we want to transform it and change the search query with the results of the Wikipedia search we wanted to do. So we get this property that is a search Wikipedia. We flat map that and only take the latest results, which means that if we are already subscribing or already searching for something and we suddenly start searching again, we will dispose the old request automatically, which is really nice. Then we can have some error handling and map that to a query result. Which means that if we, this is, so this is a component that we have written into. So we can write reactive like this. And we saw that it's loading a little bit, then it gets the results. But we don't see the drop down on this screen, but it is there. So it means that if we are doing something like this, it will not search again until we stop, and then it starts loading again. And it also means that if we click on it, reactive programming, then we see that the main program now got the notification back from the component that we searched on reactive programming. So this is really simple for the main component that only has to type this single line of code to get that search box on the page. It still needs to know how to search Wikipedia. So the component doesn't know how to do that. But this is something that takes a string and produces a stream of results so that we can give to the component. So to start summing things up, is that I think that stream processing together with React hooks can be extremely powerful. And we are solving the lifetime management of resources that, like ongoing web requests, mouse moves, web sockets. When you start something, you start some kind of side effect, and you suddenly need to dispose it. That's really simple with this. And I'm not sure that it's easy with commands. So I think it's a refreshing alternative to Elmish. You basically don't need Elmish. The good thing is that you can still use Elmish, so you can make these reusable UI components that you can just use them as one-liners in your Elmish code. And the main magic here is that we use the current state to decide what kind of stream we want to run, and when we want to subscribe it, when we want to dispose it. I discovered that this is a little bit slower than when I used it directly with Elmish, so I need to figure out how I can run my React hook code a bit faster. So I need to go to that workshop tomorrow. So that was my session. Thanks for your time. You can reach me on this email and Twitter, GitHub accounts. Hope it was